section 9.6. Page 650. And we are now translating conics, or conic sections. So what we're going to deal with today is we are no longer going to have them anchored at 0, 0. So what I want to do is I want to start with the first shape that we started with when we started this chapter, which was circles. And this is why I did this out of order in terms of the order that the book presents them. With circles, when the center was at 0, 0, our equation was what? X squared plus y squared equals r squared. The problem is, guys, that only works when the center is at 0, 0. And so we need a different equation when we're no longer at 0, 0 for our center. So now we're going to talk about our center being at a different set of coordinates. I'll talk about those coordinates in just a moment. But now we're going to go to the circle equation that you learned in geometry, which was not x squared plus y squared equals r squared. Does anybody remember what it was? You all learned it. Chapter 10 in geometry. No, that's for area. That's for circumference. That's not for graphing circles. But I'm glad you guys remember those two formulas. It makes me very happy. Why? This is the easiest thing you do in geometry. This is part of what makes second semester of geometry easier than first semester, is circles. Okay, guys, it's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where the center of our circle is h comma k. Okay? Notice that in front of the h and in front of the k in the equation is a what? A negative sign. There's a negative built into the equation in front of h and k, which means that h and k are going to be the opposite of the way they appear in the equation. Everybody clear on that? Okay? So, for example, we are now going to have something like x minus 2 squared plus y plus 3 squared equals 4. So this is a circle. Notice that x and y are both going to end up being squared here. Notice they're being added. Notice their coefficients are the same. Okay, you're going to end up with a 1x squared and a 1y squared. So this is a circle. What is the center of this circle? 2, negative 3. Very good. Because if x minus h is 2, then the h is really just what? It's the 2. The negative is part of the formula. And if y minus k is y plus 3, what must k have been? Negative 3. Because otherwise, if it was positive 3, it would have said y minus 3, but it says y plus 3. So it must have come from y minus negative 3. So h and k are the opposite of what they appear to be. The radius still works the same way. What's our radius going to be? So as far as graphing these go, nothing changes in terms of the actual graphing except what? Our center's in a different place. That's it, guys. That's the only difference. Where we start changes. Nothing else is going to change. And I want you guys to really understand that, because the same is basically going to hold true for all of our shapes. So as soon as this finishes loading, come on, you can do it. You can do it. Seriously? All right, guys, I'm not going to wait for it. No, now it's going to do it. Unbelievable. All right. Guys, I need you to stay focused on this, please. Let me pick up back to where we were. So our center is h comma k. So we had, hopefully this recording is still going. We had a little bit of a glitch there. X minus 2 squared plus y plus 3 squared equals 4. So our center was equal to 2 comma negative 3. Our radius is equal to 2. Let's see if it cooperates this time. Okay. I don't know why it found that too hard to do the first time around, but here we go. Okay. Our center now is going to be at 2 comma negative 3, which is right there. So now we've got to go 2 units in each direction, but we're not starting from 0, 0. We're starting from the center. So from the center, I go 2 to the right. I go 2 to the left. I go 2 up. I go 2 down. And then here's my circle. That's it. Was there anything really that different about that? No, we just started our center in a different place. That's it. So are there any questions about the h and the k? Notice which letter went with the gave us the x coordinate of the center? H. Which letter gave us the y coordinate? K. Which letter comes first alphabetically, H or K? H. Which letter comes first alphabetically, X or Y? X. So H goes with X, K goes with Y. If you guys understand how to do that with circles, then you now understand how to do it with all of our conic sections. I'm just going to keep going, guys. If you don't listen, then that's on you. I don't know what to tell you. This is the section that's going to get a lot of you killed. So if you choose not to pay attention to it, then let me know how that turns out for you on the test. But some of you just continue to go on with your conversation, so I'm just going to keep moving. All right. So now what we're going to do is we're going to take a look at parabolas. And for parabolas, remember that we had 2 different types of parabolas. We had parabolas that opened either this way or this way. We had parabolas that opened either this way or this way. I remember it was or, not both, not like hyperbolas, right? So these were x squared over a squared. Sorry, excuse me, guys, we're doing parabolas. X squared equals 4py, and this is y squared equals 4px. But now we're not going to have our vertex anchored at 0, 0. And so how is that going to change? Well, instead of x squared, it's now going to be x minus h squared. And instead of y, it's now going to be y minus k. Instead of y squared, it's going to be y minus k squared, because k always goes with y. And instead of x, it's going to be x minus h. It works the same way. Now, where is our vertex? H comma k. Again, we're going to be shifting these all the same way. The h and k are going to come into play in all of the equations, and they work exactly the same way in all the equations, which is what makes translating these easy. Because if you understand how it works on circles, then you understand how it works on everything. Whether or not you get the right answer is just going to depend on if you do these the way I showed you to do them. So, for example, if we have something like x minus 2 squared equals 8 times y minus 4, okay? First of all, which way is this going to open, the x direction or the y direction? Y, because y is with the 4p, right? It's the one that's on squared. What is our 4p equal to here? 8, which makes p equal to 2. What is our vertex going to be? H comma k, so what's it going to be? 2 comma 4, right? The opposite of what the x one looks like, the opposite of what the y one looks like, right? Now, be very careful on these, guys. What if the equation looked like this? Now, where is our vertex? Very good. It's still 2 comma 4. h still comes from the x parentheses, k still comes from the y parentheses, right? Remember, h always goes with x, k always goes with y. You can't put this as the x coordinate. You can't get an x coordinate from the y part of the equation. You can only get the y coordinate from the y part of the equation. So be careful there. It's not that the first one here is x and the second one is y. It's not the way it works. Okay? All right. Oh, one last what if. What if you had something like y minus 1 squared equals 4px? What is the x coordinate of the vertex then? 0. Notice that h must have been 0. That's why it disappeared. What's k? 1. You guys see how that works? So you will still see 0 coordinates. Where did our x squared equals 4py comes from? Came from h and k both being 0 because the vertex was 0, 0. We've actually been using this equation all along. We just never saw the h and k because we were using zeros for both of them. Does that make sense? That goes for all of these shapes. So these really aren't new equations. We just never saw the full version of them before. Okay. So we're going to draw this graph. Put this down here a little bit more. Okay. So our vertex is at 2, 4. There's my vertex. Which way is this going to open? Opens in the y direction, so either up or down. And since p is positive, which way is it going to open? Up. So draw your little temporary one, just like I showed you. So where's the focus going to go, up or down? Up. How far? 2 units. So we go 2 units up. There's our focus. So what are the coordinates of our focus, in case they ask us? 2, 6. We can see it right from our graph, right? Where's our directrix then? If we went up 2 to the focus, where do we go for the directrix? Down 2. Is it going to be horizontal or vertical? Horizontal. What is the equation of that line? Y equals 2. Very good. What's the axis of symmetry? Running down the middle this way. X equals 2. Right? Because it goes right down through 2 on the x-axis. Okay? What is our focal width? Yeah, it's the absolute value of 4p, which is 8. So if this thing has to be 8 units wide across the focus, how far do I go each way? 1, 2, 3, 4 to the right of the focus. 1, 2, 3, 4 to the left of the focus. We can now get rid of this temporary one, and we can draw our real one. Did I really do anything differently than we did before? I just started from a different place. Do you guys see that? That's all there is to it. Easy enough? So if you know how to do them at 0, 0, and you understand h and k, then you know how to do them anywhere. Questions on that one before we move on to ellipses? Okay, let's move on to ellipses then. And we'll just run through all of our shapes. Okay, so on ellipses, we had 2 different kinds of ellipses. We had these ellipses and we had these ellipses. And so the equation was x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1, where a is greater than b. But now we're going to put our center at h, k. So how do you think that's going to change our equations? It's now going to become x minus h squared over a squared and y minus k squared over b squared. X minus h squared over b squared and y minus k squared over a squared. Do you see that? It's exactly what you'd expect it to be after seeing circles and parabolas. So for example, let's say we had one that was x plus 1 squared over 9 plus y minus 3 squared over 16 equals 1. Okay? So what is our center going to be? Negative 1 and 3. Very good. What is our a squared going to equal? 16. Remember, A is the bigger one on ellipses, right? It's one of the differences between ellipses and hyperbolas. So A is 4. Which direction is that going to be graphed in? Well, up and down, right? So that's the y direction, right? Because 16 was underneath y. What's our b squared? Which makes b equal to? Which direction is that graphed in? The x direction. Okay, so now we can graph this thing. So we have our center at -1, 3. Right here, I'm going to put a little x. From the center in the y direction, I'm going to go up 1, 2, 3, 4, and down 1, 2, 3, 4. In the x direction, I go left 1, 2, 3. I go right 1, 2, 3. And now I can draw my ellipse. Let me get my ellipse tool here. There we go. There's our ellipse. Anything different about actually drawing that graph? Just what? The center, where we started. After that, it's exactly the same. Now, let's see how we find all of the stuff. So now we have the center. What about the vertices? What are the coordinates of the vertices going to be? First of all, which way are the vertices going? Up and down or left and right on this one? Up and down. What are the coordinates of this point? -1, 7, right? I know it's hard to see because I covered it up, but that's a 7. What is this one? So notice the only thing that's really different here is I can't write them both at the same time, can I? So you just write them separately. -1, 7, -1, -1. Okay? What it really is it's -1, 3, and then the 3 gets a plus or minus 4 on it. That's where the 7 and the -1 come from. But you can't write it like that because you have to simplify it. So you're going to write the points separately now. Okay? What about the cove vertices? What are their coordinates going to be? So we have 2, 3 right there, and -4, 3, right? 2, 3, -4, 3. Okay? What about the foci? Well, for the foci, we know that c squared is equal to what? Good. A squared minus b squared, because that's a plus. So that's going to be equal to a squared 16 minus b squared 9 is 7. So c equals the square root of 7. So the foci are going to start, and this is why I wanted you guys to do this way. What is our center? -1, 3. Leave some space. Which way are the foci going, up and down or left and right? Up and down. So as I go from the center to a focus, which coordinate am I changing? Which direction am I moving, x or y? Y. So here is where my c gets added on, added and subtracted. Okay? Anything hard about that? Not if you guys were doing the 0, 0 like I showed you, right? Now, can we simplify 3 plus or minus rad 7? Are those like terms that we can combine? What if it was just 3 plus or minus 7? Then could we simplify it? Yeah, if it was 3 plus or minus 7, then you would write it as -1, 10 and -1, -4, just like you wrote these separately. But if they're not like terms, you're done. That's it. Those are the foci. That's it, guys. That's ellipses. Do you see how easy this is if you understood how to do it at 0, 0, the way that I showed you? Okay. Hyperbolas. So for hyperbolas, we had these hyperbolas, we had these hyperbolas. This is now going to be, well, you tell me, what's the equation of this style one now? If our center is at h, k. Perfect. Minus. Falling apart. What's this one going to be? Good. Good. There you go. So, let's look at x plus 1 squared over 4 minus y minus 1 squared over, we'll do a 4 equals 1. Remember, A and B don't have to have any relationship size-wise. In this case, they can be the same. It's only on ellipses where A is bigger than B. What's my center? Good. Negative 1, 1. And be sure if it's written this way, guys, remember, the x, the h has to come from the x parentheses. The y coordinate comes from the y parentheses. A squared is equal to 4, so A is equal to 2. That's in the x direction. B squared is equal to 4 also. B is also equal to 2. That's in the y direction. Which way is this going to open, the x direction or the y direction? Why? Because it comes first. It's the positive one, so this is going to be which way it opens. So our center is at negative 1, 1 right there. I go 2 to the right. I go 2 to the left. I go 2 up. I go 2 down. Now I draw my box. Now I draw my diagonals. And it's going to open in the x direction, so it starts there and goes this way. Make sure it hits the box. It starts here and goes this way. Make sure it hits the box. There's our graph. We're done with that part. Any questions about that? Anything different than what we did the last 2 days? Not at all, right? Except where we start. It's the only thing that's different. But everything starts from there and works outward. Okay, our vertices are going to be what? Not 2, 2. 2, 2 is right there. Yeah, 1, 1. And negative 3, 1. Very good. We don't have co-vertices. I will not ask you for asymptotes if the center is not at 0, 0. Okay? Because there's a little more work to the asymptotes rather than just y equals plus or minus slope times x. You have to find the y-intercept also. Foci. So let's look for C. What's the formula for C? So 4 plus 4 is equal to 8, which makes C equal to the square root of 8, which is really what? We have to simplify that. 2 square root of 2. So the focus starts where? Negative 1, 1 is the center. Where are the foci? Left and right or up and down? Left and right. So which coordinate is changing? The x coordinate. So plus or minus 2 square root of 2. Can I simplify that at all? Nope. Just clean it up a little bit. There we go. There are the foci. Everybody see how simple that is now? Not really very scary. Now, where the method I showed you really is going to come in handy is when we write the equation of these things. So let me just do a quick example of that for you. What happens if they tell you that you have an ellipse where the center is at 3, negative 5, and let's say that besides the center we know that actually, let me tell you this. Forget the center, 3, negative 5. I take that back. They're not going to give it to you that way. They're going to give it to you this way. Ellipse with a vertex at 2, 4, and a focus at 2, 3. And we want to find the equation. Okay? But they're going to have to tell us the other focus. That's going to be the key. So they're going to tell, the other vertex. So they're going to tell us that the other vertex let's say the other vertex is going to be at 2, 3. So let's say it's at 2, 6. No, sorry. 2, let's do, I'm trying to think of something that's going to come out reasonably nice, but I guess it really doesn't matter. Let's do 2, 0. That'll work. Okay. So, we need to draw a quick sketch of this to get some idea of what's going on. And actually, I'm going to draw the sketch on graph paper this time. So it'll be easier for you guys to see. So again, it doesn't have to be a fancy sketch. You don't have to do your sketches on graph paper. You can if you want, but don't feel like you have to, okay? So, we know we have 2, 1, 2, 3, 4 is a vertex, 2, 0 is a vertex, 2, 3 is a focus. Now, before I put the focus in, can we tell where the center of this is going to have to be? Where's the center going to have to be? 2, 2. Does everybody see that? It has to be the midpoint of that segment. It's got to be right in the middle. Okay? So it's going to be at 2, 2. Now, we have a focus here at 2, 3. Where is that going to put the other focus? 2, what? 1. Do we know how wide this is? No. Which is the long direction on this one? Up, down, or left, right? Up, down, because the vertices and the foci are going up and down. So we don't know how wide it is, but we know it's taller than it is wide. So is this going to be x over a or y over a? It has to be y over a. Good. So it's x minus h squared over b squared plus y minus k squared over a squared equals 1. Everybody with me? We write down our general form. We know h and k. We said that our center is 1, 2. That's h and k. So we plug those in. X minus 1 squared over b squared plus y minus 2 squared over a squared equals 1. Now we just have to find what? A squared and b squared, right? So do we know either a or b right now? Which one do we know? Yeah, we know a squared, right? Because a is how big? From the center to a vertex? 2. So a is equal to 2. So that makes this 4. We don't know b, but we do know that c is equal to what? From the center to the focus is 1, so c equals 1. And we know that c squared equals a squared minus b squared. So 1 squared is equal to 2 squared minus b squared. Negative 3 equals negative b squared. B squared equals 3. And we're done. Now, here's the thing, guys. Any questions about how I did that? I'm sorry, the center is at 2, 2. Thank you very much. Thank you very much. Right? 2, 2 is the center, right? Thank you for catching that, Jen. Okay. Everybody okay with that? Center was at 2, 2, not 1, 2. Okay. So we end up with x minus 2 squared over 3 plus y minus 2 squared over 4 equals 1. The center is 2, 2. 2 each way in the x direction. We would go the square root of 3, which is about 1.7 each way in the y direction. So my guess as to what it would look like wasn't even that far off. But they're not going to ask you to graph this. They're just asking you for the equation. We're done. So do you see that we basically did this the same way we did before? The only thing that's different is we've got to look at the picture to count how far we're going. Now, can you guys see why I was stressing to do it the way I showed you? How well would you do at finding all of that if that's all they gave you? And you decided not to draw the picture. How are you going to come up with that equation? The picture is the key to everything. The picture is what helps you see what's A, what's B, what's C. Is it being stretched up and down? Is it being stretched left and right? The picture is the key to the whole thing. If you don't sketch it to organize your information, you're going to be completely lost. You're going to be stabbing around in the dark. Okay? Any questions about that idea? Mm-hmm. They're always going to give you enough information so that you can figure out where the center is. Now, they may do it in different ways. One way is they can give you a pair of vertices or a pair of foci. they're always going to give it to you in some way where you can find the center. Or they could flat out tell you the center and then give you a vertex and not give you a focus or something like that. Actually, they'd still have to give you the focus. So it's going to be different. If you take a look at the problems in the middle of page 655, you'll see that there's some variety. Sometimes they'll give you both vertices and both foci. That helps you find the center also, because the center's got to be in the middle of both the vertices and the foci. So it's pretty easy to narrow down. All right, any other questions, guys, before I get you going on the homework? All right, let's look at the homework then.